Hello everybody, in this video I'm going to show you a variety of different tool combinations and a proper workflow through which you can quickly and quite efficiently create a SketchUp model of a remote control, and then through topology design quickly explore different design variations for a remote control. So in the first step we have to set up our environment. I go to the scene button, and then based on if you work with metric or imperial inside units, you can set the correct system. My 3D cursor, probably by accident, is somewhere else, so I would like that one to be centered at X, Y, and Z 0. So I can press N inside the 3D view, open my property panel, and then type in 0, 0, 0 for my 3D cursor, and press Enter. And the reason why I would like to work and create my model at the world center is, on the one side, it makes managing all your object easier. And also when you bring geometry into a different application, such as Alias or SolidWorks, your objects will be imported with their original orientation from a different application. So, for example, if I would create now a cube, so I press Shift A, add cube, and I would bring this cube over into Alias, the cube would also be at the world X, Y, and Z location. Okay, so we know that the remote control we have inside the classroom has a dimension of 6-inch long, 2-inch wide, and 1-inch deep. So inside dimension I can type in 6-inch. So you see actually I can type in abbreviation or the complete name of that unit system, or I can also use the icons. Now to zoom in, I can press period on my numpad, and then it just zooms onto the object. Now I'm going to show you something I didn't mention last class. You see that dimension-wise we set up this block, and inside scale you see X, Y, and Z actually has a scale factor. So what does that mean? If I go into edit mode and, for example, I select this edge, and then inside mesh display I select length inside edge info, you will see that it says 6.562 feet. But our object is actually 6-inch long. And that is because internally this is really the correct dimension. So you see even here this edge is 656. This edge is 656, and even this one is 656. Because we artificially just scaled this object. So what we have to do now is to bake or apply the scale factor. And to do this, there are two ways. You can press Control A in object mode and then say apply scale. You can also go to object, apply scale. And just pay attention to what happens to scale and dimension when I execute this command. So here it goes. You see that dimension stays, but the scale factor is now set to 1. And if I go into edit mode, you see now that my edges really represent the correct length. So 2-inch, 6-inch, 1-inch. And that is why I mentioned that when you create like a block out of which you will design or carve your product, work with dimensions, and then scale that later, for example, can be used when we have to make a quarter scale, let's say for 3D printing. So let's say this one is too big to print, and to save material cost or to shrink the object down so it's printable, it has to be a quarter scale. I could, for example, then go ahead and type in a scale factor. But if I go to my object in edit mode, you see those are the original dimensions. And if I rewrite this back to all one, it's the same. Okay. And I also mentioned when you try to model or digitally design a product, think about all the different steps you would do inside the model workshop with foam or wood. And I, for example, in my workflow borrow a lot from those methodologies. So from a site, we know this part is slightly carved out. And with polygon modeling and subdivision surfaces, you can't unfortunately just cut something out. You have to kind of like weave in the wire mesh topology or structure so I could generate certain flows or designs. So what I have to do in this case is I can press Ctrl R, click, and then I press 0 to make sure this loop cut will be added exactly at the center. And maybe in top view I can press Ctrl R, click, and then I move it slightly forward. From this view right now, you see the dimension is inches. I'm in orthographic, so each cube is an inch. So I know if I place this one here and press enter, this loop cut is roughly positioned so that this area is 2 inches and this area is 4 inches long. So let's maybe verify this. Edge length, yeah, 2 inch, 4 inch. Perfect. So at this point, I can go ahead, maybe from below, select those points and delete them. Press X, select vertices, and then I can select those points, press F, and I selected all vertices. I can also select opposite edges, press F. It's all doing the same. Maybe select this edge, and I know that this one has to go backwards a little bit. I have my 3 widget actually turned off, so it's a little bit easier for me to see my model. And because it's symmetrical, I simply can press G to move. So I can see I can move this part, and then I press X, so I can only move it along the X-axis. I move it slightly back, like there. Okay. So this is now my really very basic blocked out model of that remote control. And now let's add a subdivision surface modifier. So I go to the modifier tab, click add modifiers, and click subdivision surfaces. Then you will see it will get a little bit rounder, more faceted. Inside view, you can maybe click on the arrow, have a level of 3. Don't go to level of 6 to make it look really round and soft, because that means the model is very dense. Something like 3 is sufficient. And you see you can still see those facets or those small faces. So to hide those, what you can do, 2 options. You can press spacebar and then type in shade and then select smooth. With my arrow keys, I go up and down, or you can go with your mouse, select it. Or you can also press T, that opens the tool property panel, and then here's flat or smooth. Okay. If you press Z, you go into shaded mode and wireframe mode. Same option you have actually down here. Solid and wireframe, bounding box. And this is a pretty dense model already. to simplify my view, inside the modifier tab, you can click on optimal display. And then with optimal display, you see that you only see few lines. Specifically, when you go into edit mode, this helps really a lot when you want to select points, because otherwise the wireframe mode or the wireframe actually starts hiding your points or makes it harder to click them. Okay, now it's time to add some loop cuts, so we can start giving this blob a more refined look. For example, I know that this edge that I selected has somewhat a much more crisper or more finer or smaller radius for the fillet. So what I can do there is I can press Ctrl R. Let me zoom in a little bit. Click on a vertical edge and then move my loop cut up and down. You can see once you add the loop cut, you can slide it. So this is called edge slide. And maybe I go to there. Don't go right next to it, a little bit below. And you can see that this command actually, I undo it, starts tightening the surface. And this is very round. Maybe I would like that to be a little bit more linear, more flat. So I could press Ctrl R and add a loop cut and move it slightly forward. And even here again, you see the closer I move my loop cut to the left, the more, for example, those edges I'm marking here right now, so those corners will be tighter. And maybe something like this. Okay. Now this one is pretty flat, but maybe I would like to have a really small minimal arc on here. So I have nothing I could grab, so I have to add a little bit of geometry. Well, there are two ways how I could do this. I could, for example, select those points, press S, and then, hold on, make sure I have bounding box. I press S and Y, so I scale them along the Y-axis to each other. That's one way. And you can see that this is a nice continuous flow, and this front part got a little bit more linear, while still being somewhat fluid. A different option would be, instead of scaling and moving those to each other, I could just press Ctrl R, add another loop cut, press 0, press enter, and then maybe I select all those points, yeah, and then I press G and X and move it slightly forward. So I give this a nice arc. And actually that works better, because this loop cut basically took care of rounding those corners, and then this loop cut basically helped me to skin this arc. Let me change these colors here. This will help actually seeing more what I'm sketching. Okay, perfect. However, because I added a loop cut, also this part here got flat. That's not really what I want, so maybe I select those. And again, selection, there are multiple ways. You can click, shift click, so hold my shift key, and I select points. If I shift click onto something that's selected, it deselects it. I can also press C and then paint over something, and with the middle mouse button I deselect. If I scroll my mouse wheel, I can increase or decrease the size of my brush. And I can press B and then draw a rectangular selection. And with left click I select, and with the right click I deselect a selection. So this is now middle mouse button, deselecting, left click, selecting. Okay. Then I press G and X and slightly move it out, and maybe go into top view so I have a better understanding of it. Yeah, because again I would like to have this nice arc. Okay, that looks good. What else can we do? From a side view, I really don't like that this is linear. So I will go ahead and maybe select these points, press G and X, move it slightly over, and then I pay close attention to how far it changes. And it's sufficient. That looks good. Okay. Also from below, this part is very flat. Now your palm is actually rather round, so I would like this to be more spherical. So what can I do? Well, I can select those points, and then I press S and Y and scale them to each other. I can press G and Z and maybe move them down in this view. So I basically put them on a spherical outline. So that's the way how they were before. So with G and Y, I can move them up, and then S and Y, I scale them in. I think I said G and Y, move them up, I meant G and Z. And you see, I work a lot in orthographic views, and I always make use of my 3D system, lower left corner where my mouse is. That always tells me the axis orientations. And you also see the green and the red line inside 3D view. So this, for example, looks more comfortable in my hand. Okay. And I mentioned when you put in batteries, the batteries are linear. Now this lower part is actually arced. So I have to add a little bit more geometry to force that rather curved geometry to become a little bit more straight. And that's sometimes a little hit and miss to see where you have to put something and how many loop cuts. So I press Ctrl R from a side view, click, let's press enter, and let's see maybe if it's straight. And it nearly looks straight, but it most definitely is not. So I'm going to create another cube, move it down, bring it to there, try to compare, and you can actually see that it's slightly curved. So why does that happen? Think about when you work with this geometry or this technology with modeling subdivision surfaces, and with NURBS the same. This is like a very flexible material, kind of like when you take a strip of plastic and you bend it and you let it loose, it wants to get straight again. And think about those points kind of like as poles. You bend something over. This might be a little bit abstract, but hold on. Let's go to boat hull design. I think this actually visualizes it pretty well. So, for example, here, that's the inside of a boat, and you see all those kind of like cross sections. And then on the outside, they will put all the wood planks over it. So let's say Fisher boat. Oops. And let's see when we find a good picture. Unfortunately, no, we don't. Ah, here. So inside you have this cross-section design, and now what you put outside, those are all wood planks, and they're basically pressed over those cross-sections. And in 3D, those points are actually your cross-sections. And the surface, think about those as your wood planks. You force inside. So that means that if I would like to have this part more straight, I need maybe 2 loop cuts. Let's see what happens. And let's add a plane. Let's move it up. There we can see now that a certain part is really straight and then it starts arcing. And that's simply because I have 1, 2, 3, 4 points that's in a line. And that means that between these 2 points, the surface will be straight. If, for example, I move this one up, you see immediately here how the surface started to bend. See that? Same, for example, here. Then this area will curve. Okay. There's another modifier I would like to introduce you right now before we continue with the buttons. My object is very symmetrical, and let's say now I really would like to quickly explore different proportions and styles. For example, from the top, this part right now, this line is parallel. Maybe I would like it to arc. So what I do on the one side, I have to do on the other side at the same time. And I can make myself work a little bit easier. So I select all the points that are on one side. So I do not select the cross section, just those points on the side. And I press X and delete. So I open my model. And then I go back to the modifiers, click Add Modifier, and select Mirror. And if you pay attention to it, like in my case, you see I have something in addition. It looks a little bit odd, self-intersecting, and that's because this one is set up incorrectly. So my axis is actually Y, as you can see. So Y is perpendicular to my remote control, but the axis inside the mirror modifier is X, so I can uncheck X and check Y. Now I have like a full model again. However, you notice that the ends are a little bit creased. So why does that happen? So what you have to understand is, this is kind of like a sequence, a modifier stack. So this half model with the first modifier, subdivision surface, we make soft. And then this half model, the end result of that geometry, we give to the mirror modifier to flip it over to the other side. So what we want is actually this. So I move the mirror modifier up by clicking on the up arrow. So I have this half, which I flip over, create a solid model, and then this end result, the big model, I pass to the subsurface modifier, then to soften it. So whenever at the beginning you work with subsurface and mirror and you have those pinches at the meeting, like center, that's because your order is wrong. And you can change this by simply clicking on those arrows to move the modifiers up and down. Because now I could go ahead and, for example, maybe select those points, say Shift S, cursor to selected. So you see I move my 3D cursor to there. Inside pivot point, I set my pivot point to be the 3D cursor. And then I can select with B all these points. And then in top view, if I press R, you see that it rotates around the 3D cursor. That's why, for example, I like using it a lot. And because I only work with one half, I don't really have to work on the other side because the mirror modifier just flips over the result to the other side. Okay. So that's the end of the video for how to create the basic body for a very soft and organic looking remote control.